Today students, in probability we are going to see one more problem. A coin is tossed thrice, three times. Thrice means three times. So a coin is tossed three times. Find the probability of getting exactly two heads or at least one tail or two consecutive heads. So in this problem, if you read, I am going to take three cases given. The coin is tossed three times thrice. So you have to find out three cases. So here, but it is given either or condition. So in probability, we know in either or condition, we have to use the formula P of A union B union C. Suppose you assign probability of getting exactly two tails. If I assign A, I am taking A equal to probability of getting exactly two tails. Then I am taking B equal to probability of getting at least one tail. A is probability of getting, see it's given, find the probability of getting exactly two heads. So A is probability of getting exactly two heads, not tails, two heads given. And B is second one, or at least one tail. So B is probability of getting at least one tail. Then C, naturally next one what is that? That only will be C, two consecutive heads. So probability of getting two consecutive heads. Okay, we are assigning A, B, C. And it is given, condition is given either or. See, probability of getting exactly two heads or at least one tail or two consecutive heads. So in probability, we know the formula you have to apply to find R, or if it is given many, you have to take P of A union B union C. In set language, you studied same formula, N of A union B union C. Same way here it is P. Probability we are using same formula. First you write all the three variables whatever you have taken, write separately. P of A, P of B, P of C. Then when you take intersection, minus P of first two, A intersection B, minus then second B and C. P of B intersection C minus P of first and last A and C. A intersection C. Again plus will come. If it is union here intersection will come. P of A intersection B intersection C. Suppose we can take, sometimes if they ask this one means A intersection B intersection C, you can take LHS A intersection B intersection C. Same formula, but in the end A union B union C will come here. So no need to by heart the formula. Just remember in mind, if you take one A, B, C, first we are taking A separately, P of A plus, but with the plus sign, P of A plus P of B plus P of C. Then minus, when it is intersection, remember we are taking minus. So A intersection B, A and B, remember first two, then next two, B and C, B intersection C, then third A and C, A intersection C. Then again we are coming to intersection only, but all the three, so plus last term plus B intersection C. So now we need to find out, to find this R probability of getting two heads, A or B or C. To find out, you have to use this formula. That means we need to find P of A, P of B, P of C, then A intersection B, B intersection C, A intersection C, then A intersection B intersection C. We know in probability formula is P of A is equal to N of A by N of S. That means we need A, B, S, everything. So first find out what is S sample space. Already I taught in one video session, three coins means take first all the edge and one edge in front, 2T, then H in the middle, 2T in the corners, and then H at the last, 2T in front. Then now 2H 1T. So 1T in front, 2H second and third place, then H middle place T, first and third place H, then first two places H, last place T. That is, we are taking all the three heads and two tails, one head. Now from here three terms you'll get it, then one tail, two heads, again three terms will get. First we have tried, suppose one head in front, middle, last, two tails other sides in three places. Same way here, one tail, two heads, so one tail in front, middle, last. Now all the three tails are getting. This is only fluke method you can remember. So n of s is sample space. Naturally if you count you are getting 8. Now what is A condition? You have to find out A. What is A? A is given probability of getting exactly 2 heads. So here if you see in the sample space, exactly means accurately only 2 heads must be there, not more than 2 heads. And it should not be less than 2 also. So heads must be 2, H must be 2, not above or below. So how many here? You take which other one here? T, H, 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 T, H. The places may be anywhere. It is nothing mentioned. It is just given exactly 2 heads. That's all. And here one place. Understand? I hope children you understand. So how many coming here? 1, 2, 3. So n of A is 3. N of A equal to 3. That means P of A means you know n of A by n of S. So 3 by 8. You know the formula. P of A is n of A by n of S. 3 by 8. Now next your condition is given. B is probability of getting at least one tail. So we have to find out B. At least one tail means, remember the word, it can be more but not less. At least one tail means it can be one tail or two or three. So what are things coming here? Here no tail at all, so this won't come. Here this will come because more than one tail, but one tail is there. Here two tails, so we can take this, you take. So you can take H, T, 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 H, T, 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 H. This also you can take because one tail is there. What is the meaning? One tail or more than one tail must be there, but not without T. If it is there, we cannot take it. So H, H, T and T, T is there, so you can take. At least one means either 2 or 3, but tail must be there. H, H, H we cannot take because no tail at all. So how many you are getting? 1, 2, 3, 4, 5, 6, 7. So n of B equal to 7 you are getting. That means P of B equal to n of B by n of S formula. So you are getting P of B is equal to 7 by 8. Next we have to find out C. What is given C? Probability of getting 2 consecutive heads. What is consecutive meaning? Continuously it must come. If you take any H, if you take in the sample space, it should not be here. See, if you see head, 2 heads, if you see, one is in this place, one is in this place. It is not continuous. Continuous consecutive means next place H must be there. 2 H must be together. Here this is there. So this we can take. And here also 2 consecutive heads. Here also 2 consecutive heads. Doesn't mean that strictly 2 heads. It may be 3 heads also. So we can take here 3, all the 3. Two heads continuously here, T, H, H. Then here it is not continuous, so here H, H, T. So this also we are getting n of C equal to 3. So P of C is same formula, n of C by n of S. So P of C is equal to 3 by 8. So we finished finding P of C. Now we have to find out A intersection B. So you have to find out A intersection B. So what is A intersection B? What is the meaning? A is probability of getting exactly 2 heads. B is probability of getting at least one tail. So your condition is whichever you are taking here in sample space, it must satisfy both the condition. It must be exactly 2 heads. So 2 heads must be there and getting at least one tail. 1 or 2 or 3 tails can be there, but 2 heads must be there. So 2 heads, where is 2 heads here? So 1 tail is there. So this can be taken. See here also 2 heads, 1 tail. So we can take T H H, then 2 heads, 1 tail. No successive, nothing mentioned here. So here condition is only exactly 2 heads, at least 1 tail. So at least 1 tail means you can take this one also. Same way H T. The condition, remember, tail 1 must be there and 2 heads must be there. So here how many are getting? N of A intersection B equal to 3. So P of A intersection B, same formula only you have to apply. N of A intersection B by N of S. Here also you are getting P of A intersection B is equal to 3 by 8. Next we have to find B intersection C. What is a B condition here? B condition is probability of getting at least one tail. Okay, but C is probability of getting 2 consecutive heads. So remember in this 2 condition how it will satisfy. One T must be there, and when you see other condition 2 heads continuously it must be there. So one tail, 2 heads continuously. If you see here, this is one THH. So you are getting THH, 2 consecutive heads. So it must be together 2H. So this one and this one. This one we cannot take. So HHT. Yeah, I hope children you understand. 2 consecutive heads and at least 1 tail means 1 T must be there definitely, and 2 heads together. So you are getting P of B intersection C equal to N of B intersection C by N of S. N of B intersection C is 3. Sorry, 2. 1, 2. 2. So you are getting 2 by 8. Next we have to find out A intersection C. What is the A condition? Check your condition. Probability of getting exactly 2 heads. C is probability of getting 2 consecutive heads. So it must be exactly 2 heads but 2 consecutive heads. That means what you are getting? Exactly 2 heads, tail and all nothing here, and 2 consecutive heads here. So you are getting HHT and THH. There's only 2 consecutive heads and exactly 2 heads. So this 2 only applicable. So you are getting THH HHT. So you are getting probability of A intersection C is same formula, you write it 2 by 8. So you are getting, you got the answer for P of A, P of B, P of C, P of A intersection B, P of B intersection C, P of A intersection C. Now you have to find out P of A intersection B intersection C. So we have to find out P of A intersection B intersection C. What is A? All the 3 conditions must be satisfied. Getting exactly 2 heads, but heads must be successive and 1 tail must be, at least 1 tail must be there. So if we see like that, exactly, this we cannot take because 1 tail is not here. So exactly 2 heads, but that heads must be 2 together and with 1 tail. So this 2 only applicable, THH and HHT. So we are getting THH HHT. This only satisfied all the 3 conditions. So you are getting N of A intersection B intersection C is equal to 2. So P of A intersection B intersection C is 2 by enough is 8. Now we have to find out all the condition, whatever we need, it is satisfied. We finish finding P of A, P of B, we finish P of C, and P of A intersection B we finish finding P of B intersection C, and we finished P of A intersection C, plus we finished P of A intersection B intersection C. All this we finished. Now we have to apply the values here, substitute the values here. What you got the value P of A? P of A value, what we got is here 3 by 8. P of B 7 by 8. So substitute here. P of A 3 by 8. P of B 7 by 8 plus what is P of C we got? P of C is 3 by 8 and A intersection B 3 by 8. So 3 by 8, A intersection B 3 by 8, so minus 3 by 8. And B intersection C what we got? 2 by 8. And A intersection C also 2 by 8. So substitute here. Minus 2 by 8, minus 2 by 8, plus A intersection B intersection C we got 2 by 8. We know in mathematics, denominator same number, just that itself you can take it as LCM, and whatever numbers in the numerator with the sign you can write here. So remember children, you are doing mistake only in this part. When you are doing simplification, when there is fraction plus and minus, you are going wrong. If it is different number, you have to find the LCM by prime factorization method, then you have to do it. In either sum, if I come across, I'll teach you that. But now it is all the LCM same, means all the numbers in the denominator same, take it as a LCM right here. And numerator, whatever number is that plus or minus sign, with that you have to write it. So getting 3 plus 7 plus 3 minus 3 minus 2 minus 2 plus 2. First what I am going to do is plus and minus same number will cancel it. 1 plus 3, 1 minus 3 can. Same way 1 plus 2 minus 2 cancel. Remaining numbers will simplify. So plus number will add it, minus number will add it. Here plus number is 3 plus 7, 10. Any other plus number? No. So 10. Here only 1 minus 2 is that, 10 minus 2 by 8. So this is equal to 10 minus 2 is what you are getting? 8. So 8 by 8, it will get cancelled, you are getting 1. So your answer is P of A union B union C is equal to 1. That is what is which one answer? Probability of when they toss the coin thrice, find the probability of getting exactly 2 heads or at least 1 tail or 2 consecutive heads. So for all these 3 conditions, the answer is 1. I hope children you understand. Thank you for watching.